Hello and welcome to Lesson 1.5, Angle Relationships. We just talked in the last lesson about how to measure angles and classify them, but now we're going to look at pairing angles together in different relationships. So for the most part today, we will be talking about two angles at a time. So we've measured and classified angles before. Now we're going to use special pairs of angles, and we'll also be identifying perpendicular lines. So here's your list of vocabulary. We will talk about what adjacent angles are, linear pair, vertical angles, complementary angles, supplementary angles, and perpendicular in just a little bit. So first, let's talk about some pairs of angles. Many pairs of angles have special relationships either because of the measurements of the angles in the pair or because of the positions. So we're going to talk about the positioning first. Pairs of angles based on positions, we have the term adjacent angles, and adjacent in basic terms means next to, sharing no common interior points. They're going to share a side and a vertex. A linear pair is a special kind of adjacent pair of angles where the non-common sides form opposite rays or a straight line. Okay, think of a speedometer where we have our needle going from one end to the other on a straight line here, and that would be a linear pair. The pair of angles form a line with their non-common sides. Okay, 1 and 2 are only adjacent, 3 and 4 are also a linear pair. So I want you to try and think of an example when two angles would have a common vertex but not be adjacent, and then also common side but not be adjacent. See if you can draw those on your paper. Alright, if you can't think of anything, or if you already have yours drawn and you want to see what we should have, something would look like this if they have common vertex but not adjacent. If I have angle 1 here and angle 2 there. Angle 1 and 2 have a common vertex but they're not adjacent. They don't share a side. Now, if two angles have a common side but are not adjacent, they could be formed like this. There's angle 1 and there's angle 2. They have a common side, but they do not have a common vertex, so they're not adjacent. So let's try example 1. We want to tell whether the angles are only adjacent, adjacent and form a linear pair. In that case, we're just going to write linear pair. We don't have to write both of those. But if they're not adjacent, that's what we'll write for not adjacent. Okay, so let's look at 5 and 6. 5 and 6 have a common vertex, common side. Their non-common sides form a straight line, so 5 and 6 are what we call a linear pair. You can abbreviate pair as PR period. Okay, 7 and then angle SPU, and I'll show you why we don't refer to that as a number. Angle 7 and SPU, they have a common vertex, they have a common side, but notice 7 is part of SPU. 7 and 5 make up SPU, so we are not going to say that these are adjacent because they have common interior points. Not adjacent. Let's look at 7 and 8. 7 and 8, they have a common vertex, but they have no other commonalities, and so these are also not adjacent. Now, we didn't really have one that was only a pair of adjacent angles. See if you can name a pair of angles from this diagram that are only adjacent. Alright, the first pair I see are 7 and 5. Angle 7 and angle 5 are an example of only adjacent. Alright, now we have some pairings of angles that compare and relate these angles based on their measure. And those are the ideas of complementary and supplementary. Complementary angles are angles whose sum measures 90 degrees total. So if I were to combine them, I get 90 degrees total. So we have A and B, 37 plus 53 is 90. So A and B are complementary angles. But then if I look at A and C, 127 plus 53 is 180 degrees, and so they are what we call supplementary angles. Here's a quick little trick to help you remember which one means 90, which one means supplementary. If I write CO for complementary, I just draw a line down from that C, making it a 9. There's my O for a 0, 90 degrees. For 180 for supplementary, I can write S for supplementary, and I can turn that into an 8 of the 180 degrees. Again, these are angles whose measures total 90 and 180 in pairs. They're always a pair of angles. 2 angles, 2 angles. Now, the supplement of an angle is where we take 180 minus that angle measure. The complement of an angle is where we take 90 minus that measure. Okay, so if we have one angle at a time, the complement of A would be B, 37 degrees. The supplement of A would be C, 127 degrees. So let's find the measure of each of the following. Let's find first in example 2a, a complement of angle E and F here. Complement means we're going to take 90 minus the angle measure. All right, so the complement of F is 90 minus the measure of F, which is 59. And 90 minus 59 is 31 degrees. But when we have an expression that doesn't give me an exact value, they use variable expressions like this, I'm going to do 90 minus, and then I have to write that parentheses. I have to put the parentheses there. Because of this, you're subtracting both parts of this. Subtracting 7x isn't a problem, but I'm actually subtracting negative 12. Minus negative 12 is actually plus 12. So 90 plus 12 are the two parts of this that I can simplify. 90 plus 12 is 102. And so I can express the complement of angle E as 102 minus 7x degrees. Same kind of thing with supplements. We can find the supplement of F by taking 180 minus the angle measure. This is my angle symbol. So go ahead and do the supplement of F. You can do that part. And we should get the following answer. 63.5 degrees is what we get when we take 180 minus 116.5. But for the supplement of G, we're going to take 180 minus, again I have to write the parentheses around 7x plus 10. In this case it doesn't have as much to do with this, except when we do minus positive 10, it's actually 180 minus 10 that we're doing. 180 minus 10 is 170. And then I leave my minus 7x. Now, we could put the minus 7x in front, plus 170, and write it that way, and that's okay. A lot of times you'll see me write answers in this form, where we put the x term first and the constant term after. All right, so let's talk about example 3. If we are told that an angle is 10 more than 3 times the measure of its complement, and we're asked to find the measure of its complement, here's what I want us to do. We're going to let our one angle measure be represented in terms of x. We're just going to say x equals the first angle measure. And then I can express the rest of this in terms of x. So when it says an angle is, I can replace that part, an angle is, with x equals. 10 degrees more than becomes 10 plus 3 times the measure of its complement. So I'm going to do 3 parentheses, and I'm going to write an expression for the complement of x. Complement of our angle, x, would be 90 minus x. And so I'm going to fill in 90 minus x in that parentheses. Now we're going to solve this equation for x. The first thing we should do is distribute. So I have x equals 10 plus 3 times 90 is 270. 3 times negative x is minus 3x. I can combine like terms here, which gives me 280. And I can add 3x to both sides. So I have 4x equals 280. And lastly, we divide by 4 to get that x equals 70. 280 divided by 4 is 70. Now, that is the first angle measure we found. We found x is 70. The complement of x would be 90 minus 70, which is 20 degrees. So our complement, 20 degrees, is our final answer. All right, I'm going to give you a moment to try and set up your equation for the supplement when we know the measure of two supplementary angles is the difference. If we know the difference is 32. So take a look at that, see if you can set up an equation. If you need more time, pause the video. Otherwise, this is what we should get. We get an equation kind of like this. I called one of my angles x. I don't want to call my other angle a different value because I know it's the supplement of that angle. So I know I can call the other angle 180 minus x. So I'm going to take x for one angle, and we're taking the difference of their two measures. So I'm going to take x minus the 180 minus x and set it equal to 32. When you distribute the minus to both of these, we actually have x minus 180 plus x equals 32. Both x's become 2x. And if I add 180 to both sides, I get 2x is 212. And divide by 2, and that's going to give me one of those angle measures. X is 106 degrees. That's the first angle measure. And they want both of the angle measures, so I'm going to have 106 degrees. And then if I take 180 minus 106, I get 74 as my supplement. And if you were to subtract 106 minus 74, we do get a difference of 32. All right, the other kind of angle pairs we're going to talk about are, again, organizing these angles by their positioning and their measure, because we have vertical angles which are formed by two intersecting lines, and they're non-adjacent, meaning they don't share a side. So 1 and 3 are considered vertical, 2 and 4 are considered vertical. Vertical angles are going to be opposite of one another in the X pattern. So 1 and 3 are opposite, 2 and 4 are opposite. And what you notice is that vertical angles are always congruent. So their measures will always be equal. So let's try example 4a. I want you to name a pair of vertical angles. Well, if we look in this diagram, angle HMJ and angle KML are vertical angles. It's not the only pair we could come up with, but it's a pair. And now I want us to use the same concept here to find the value of the variable. Remember, vertical angles are congruent. And so here's what we can do. We can find the value of each of these variables by doing a couple things. To find y, we simply set these values equal to each other, and I have to find y before I find x because I have two expressions with y and only one for x. So I'm going to set 2y plus 6 equal to 8y minus 102. I want you to take some time, solve that equation. You'll need to pause the video, but once you have the equation solved, go ahead and click play, and this is what we should get for y. We should get that y is 18. You subtract 2y from both sides, then you can add 102 to both sides and divide by 6. We get 18 equals y. So that's the value of one variable. To find what x is then, I'm going to need to know this angle measure. Well, 2 times 18 plus 6 is 42 degrees. Now I'm going to go back to my concept of supplementary angles, because if I have a linear pair of angles, which I have here and here, those will always add up to 180 degrees because they form a straight line. So I can take 42 away from 180, and this gives me 138 degrees, which is the same as 3x. So to find x, I simply say 138 equals 3x, divide by 3 on both sides, and we get that x is 46. So x is 46 and y is 18. All right, next, notice we're jumping to example 3. That's a typo, don't worry about that. We are going to talk about perpendicular lines. Perpendicular lines always intersect such that you get right angles. So we want to find x and y so that DG and BE are perpendicular. That means I want 2x and 4x to total 90 degrees, and I want 5y plus 20 to be 90 degrees. So all we have to do are set up these two equations. And if